Microgrids are localized energy systems designed to generate, distribute, and potentially store electricity for a defined area, such as a neighborhood, campus, military base, or industrial site. Though smaller in scale than conventional wide-area power grids, microgrids serve the same fundamental purpose, ensuring a reliable balance between electricity supply and demand in real time. Despite their size, microgrids are not a new concept. Historically, isolated systems serving small communities, islands, or private industrial plants operated independently, effectively functioning as microgrids long before the term became widespread. Over time, most of these standalone systems were interconnected to form regional or national power grids. Today, however, microgrids are experiencing a resurgence due to the increasing demand for resilient, cost-effective, and sustainable energy solutions. Microgrid definition and classification. A microgrid is defined as a localized network of electrical components comprising both power sources and loads managed by a single, centralized control system. This system can operate in sync with the main utility grid or function independently island mode, depending on technical and economic conditions. The shift from traditional centralized power systems toward microgrids is driven by several factors, including rising fuel costs, concerns about power quality and availability, infrastructure aging, vulnerability to natural disasters, lack of advanced control systems, and the growing impact of climate change. In response, microgrids have emerged as a modern, adaptable solution within the evolving energy landscape. Types and key drivers. Based on this definition, microgrids can generally be categorized into two primary configurations: on-grid and off-grid, each with two distinct subtypes. On-grid microgrids, these have access to the national grid or wholesale electricity markets and are further classified into, using existing utility lines, no control over the broader grid, using private infrastructure allowing for grid control and possible islanding operation. Off-grid microgrids. These operate independently without any connection to the national grid, typically deployed in remote or isolated regions such as mountainous areas or islands, developing or underserved regions with limited grid infrastructure. These different configurations result in varying key business drivers for deploying microgrids. Instead of trying to meet all possible goals, it's more effective to focus on the specific problem your market faces and how a microgrid can address it. The primary drivers include cost-effective energy pricing, improved resilience to grid outages or disruptions, reliable energy availability in underserved or remote locations. Off-grid microgrids, powering remote and isolated communities. The off-grid microgrids are typically deployed in locations where access to national or regional electricity networks is either physically impossible or economically unfeasible. This includes islands, remote communities, and isolated industrial operations such as mines or research stations.